Okay, let's get the last few topics in this chapter. Earplugs, just some safety things. Earplugs block sound waves from entering the ear canal. It's a really simple way to uh, to decrease the amount of sound that enters your ears. I like to use the wax ones, but you can also get the foam ones where you have to sort of twist them up and stick them deep down into your ear canal. But you can also buy these wax earplugs that just sort of go into the outer part of your ear, and I find that those are much more effective. Those are also really good for swimming if you just want to keep water out of your ear canal. Um, these are rated by the noise reduction hearing, or noise reduction rating, excuse me. Are the NRR. The NRR is in decibels. Remember decibels, that would be like our delta L. What is our delta L? And if I have, say, a rating of a delta L of 20, then that would mean that it would decrease the intensity by a factor of 100. Or if I had a delta L of 50, then that means it would decrease the intensity by a factor of, well, 10 to the fifth, which would be, what, 100,000. So, for example, a rating of 20 decibels, oops, should decrease the intensity by 1 over 100, by a factor of 100. This is our delta L. This is our new intensity. It's going to be 1/100th of the original intensity. Another means of sound reduction involves interference of waves. This is kind of interesting. So listen up. Remember the video that I showed you of the whales creating the huge waves to kill the innocent seal? Uh, if I have two waves that add up like this, then they create a wave that's bigger, like the one that the whales use to kill the seal. But if I take these waves and make them interfere in a different way, if I make them interfere in this way, see, notice up here the peaks and the peaks lined up and the troughs lined up, and it made to give you a bigger peak and a bigger trough. So what do you think is going to happen if I make my waves line up like this, where the peaks and the troughs line up? Well, what's going to happen is I'll get nothing at all. That you'll get a wave that just goes away. If you're ever out on the water, on the open water, in a really still lake, you can watch the wakes from boats, and you can actually observe this phenomenon. It's a little tricky, and you sort of have to watch. But you'll see sometimes waves will come together and they make bigger waves, and sometimes waves come together and they make smaller waves. Or they even make no waves at all. So another means of sound reduction involves the interference of waves. And these are in noise-canceling headphones. What they do is they detect the ambient noise and they produce an out-of-phase sound wave to cancel the outside sounds. What it means to be out of phase is that I have one wave like this and the other wave like this. When I add up these two waves, I get nothing at all. And so if I imagine, here I am sitting listening to my headphones, uh, I have some sort of noise that's coming out. Let's say that that noise is a wave function that looks like this. Then the headphones make a wave function that look like this. And when those add up, those go away and they become nothing at all. So those are noise canceling headphones. I don't have any. I don't think I'm wealthy enough to have them. But they're really great. They don't actually block the noise. They just create a new noise that will cancel out the ambient noise.